This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on graphing tangent and cotangent functions. So let's recall our unit circle. The x value is cosine, the y value is sine. So we're going to look at negative pi over 2 down here and positive pi over 2 up here. At negative pi over 2, the x, the cosine value, is 0. The y, the sine value, is negative 1. At 0 radians, the cosine is 1 and the sine is 0. Cosine is 1, sine is 0. And at pi over 2, the cosine is 0 and the sine is 1. Cosine is 0, sine is 1. But I've written sine first because tangent is sine divided by cosine. Negative 1 divided by 0 is undefined. 0 divided by 1 is 0. And 1 divided by 0 is undefined. So a tangent function is undefined at negative pi over 2 and pi over 2. The tangent function will have an asymptote at negative pi over 2 and pi over 2. So that's the first thing we want to identify is our primary period from asymptote to asymptote for the tangent function will range from negative pi over 2 to pi over 2. So we have that nice bit of information for us to consider. So if I'm graphing a tangent function, I'm going to start by graphing the asymptotes. You'll notice here's pi, here's negative pi. I have an asymptote here in blue at pi over 2 and an asymptote in red at negative pi over 2. So my tangent function's primary period is going to fit somewhere between negative pi over 2 and pi over 2. As we graph these trig functions, we want to go from starting point to ending point. Starting point is the first asymptote. Ending point is the second asymptote. The midpoint is halfway between. The midpoint between negative pi over 2 and pi over 2 is 0. And we know the tangent of 0 is 0, as we saw earlier. What about our quarter points? Halfway between negative pi over 2 and 0. Negative pi over 2 is negative 2 pi over 4. And 0, halfway there would be negative 1 pi over 4. And my quarter point between 0 and the ending one, 0 and 2 pi over 4. Halfway between 0 and 2 pi over 4 is positive 1 pi over 4. So starting point, ending point, midpoint, quarter point, quarter point. Of course, the starting points are really starting asymptotes, but we have 5 values we need to get to graph our tangent function. So starting point, negative pi over 2, ending point, pi over 2, 0 is the midpoint, quarter point, negative pi over 4, quarter point, pi over 4. If I want to figure out the tangent, remember tangent is sine divided by cosine. And as we saw, negative 1 divided by 0, undefined. First asymptote, 1 divided by 0, undefined. Second asymptote, 0 divided by 1, midpoint is 0. So we're going to add our quarter points. At negative pi over 4, sine is negative 1 over root 2, cos is positive 1 over root 2. Why is that? Negative pi over 4 is down here in the fourth quadrant. Sine is negative, cosine is positive. The reference angle, pi over 4. Sine of pi over 4 is 1 over root 2. Cos of pi over 4 is 1 over root 2. So fine, the sine is negative, the cosine is positive, but the numbers are the same. This divided by this just gives me negative 1. Pi over 4 up here, 45 degrees in the first quadrant. Sine and cosine are exactly the same. They're both positive in quadrant 1. 1 over root 2, 1 over root 2. A number divided by itself gives us positive 1. So once I have those numbers, I have enough for me to go ahead and plot those 3 points between those asymptotes to go ahead and get our graph. So you can see the way this graph paper is laid out. 1, 2, 3, 4 boxes for pi. So this is pi over 4. That goes up to 1. 1, 2, 3, 4 boxes for pi. This is negative pi over 4 down to negative 1. And again, you can see we have the asymptotes in here at pi over 2 and at negative pi over 2. So we're going to draw that through those 3 points, heading towards the asymptotes, to get our equation, to get the graph of our function. So here's our primary period with those 3 points. There's the 2 asymptotes, and there you can see how the graph heads towards the asymptotes as it goes through. And then you can also see that we have many others that are showing up as we zoom it in or zoom it out. So zooming it in, This is our primary period from asymptote to asymptote. But zooming it out, you'll recognize we can have many, many, many others. But always go from asymptote to asymptote. Starting point is the left asymptote, ending point is the right asymptote, midpoint, and then quarter point, quarter point. That will be our strategy for graphing tangent functions. Well, the reciprocal of tangent is cotangent, and cotangent is cosine divided by sine. So this time let me go ahead and put cosine first and sine second. Cosine of 0 is 1, sine of 0 is 0. So 1 divided by 0 is undefined. Cotangent will have an asymptote at 0. Cosine of pi over 2 is 0, sine of pi over 2 is 1, 0 divided by 1 is 0. Pi, cosine of pi is negative 1, sine of pi is 0. So here's 3 points. Starting point is 0, ending point is pi, midpoint is pi over 2. Asymptote at 0, asymptote at pi, but then the point 0, 0 is our midpoint. So those are the first things we start with. And we always want to go from asymptote to asymptote. Again, asymptote at 0, cosine is 1, sine is 0, 1 divided by 0, undefined. Asymptote at pi, cosine is 1. Actually, cosine is negative 1 there. See if I can fix that. And I think I have. Negative 1 divided by 0, also undefined. That'll be an asymptote. At pi over 2, cosine is 0 and sine is 1. 0 divided by 1 is 0. At pi over 4, cosine and sine are the same, both 1 over root 2. Cosine divided by sine is positive 1. And then at 3 pi over 4, our other quarter point, right? Halfway between the starting point and the midpoint, between 0 and pi over 2, is our first quarter point, pi over 4. Halfway between pi over 2 and pi, 2 pi over 4, and 4 pi over 4 is 3 pi over 4. And the cosine of 3 pi over 4 is in quadrant 2, so that's negative, but the sign is positive, and then we get a value here of negative 1. So we have asymptote at 0, asymptote at pi, pi over 4 yields 1, pi over 2 yields 0, 3 pi over 4 yields negative 1. Let's go ahead and graph those 3 points and those 2 asymptotes to see what the cotangent function is going to look like. So here's our asymptote. It's the y-axis, x equals 0. Our other asymptote, x equals pi. Pi over 2, 0 is our midpoint. Pi over 4, sine and cosine are the same. Divide them out and are going to get positive 1. 3 pi over 4 puts me in quadrant 2. Sine and cosine have opposite signs, but the same value, the same number. Divide those, I get negative 1. So these are the 3 points I need for my cotangent function. What will that look like? Coming down this way, bending, and then going towards the asymptote. Let's go ahead and graph that cotangent function. So here's our primary period. You see those 3 points. Asymptote at 0, asymptote at pi. If I zoom it in, we can look at it a little closer. So there's our fundamental period with those 3 points and the 2 asymptotes. Zooming it out, of course, we can see many, many, many more versions of cotangent x. But the process is the same. For tangent or cotangent, go asymptote to asymptote, midpoint, quarter point, quarter point. Notice the cotangent function is always going down, whereas the tangent function was always going up. Cotangent is a decreasing function. From left to right, it's going down. Tangent is increasing. From left to right, it's going up. So here we're going to take a look at y equals tangent of x minus pi over 3. Now you could just graph y equals tangent x and then shift the asymptote to the right pi over 3, shift the midpoint, quarter point to the right pi over 3. Nothing wrong with that strategy. I'm going to be a little bit more precise here though and go through the whole process of going from asymptote to asymptote, computing what those values are, and then finding midpoints and quarter points. So we know that one of the asymptotes for tangent is negative pi over 2. So I'm going to solve x minus pi over 3 as negative pi over 2. Adding pi over 3 to both sides, what do we get? 2 pi minus 3 pi, that's negative 1 pi over 6. X equals negative pi over 6 is my first asymptote, so that we can graph. My second asymptote for tangent is usually pi over 2, so the thing in the parentheses has to equal positive pi over 2. So x minus pi over 3 is positive pi over 2. Adding pi over 3 to both sides, pi over 3 to plus pi over 2, 2 pi plus 3 pi, 5 pi over 3 times 2 is 6. So we have asymptote, we have asymptote. The midpoint is halfway between. If I add negative pi over 6 plus 5 pi over 6, I get 4 pi over 6, 2 pi over 3. and then take half of that. That'll give me 2 pi over 6, or pi over 3. So that's my midpoint value. And then my quarter point, to get the quarter points, I've got to go from negative pi over 6 to pi over 3, which is 2 pi over 6. Add those together and take half of that. So negative pi over 6 plus 2 pi over 6, which is pi over 6. Take half of that, you get pi over 12. To get the third quarter point, I've got to go from midpoint to asymptote. So midpoint pi over 3 to 5 pi over 6, or if you like, 2 pi over 6 to 5 pi over 6, and then take half of that. That's a half of 7 pi over 6. That'll give me 7 pi over 12. So I have midpoints, I have asymptotes, I have quarter points. And then we know what the tangent function looks like. The tangent increases. It's at -1, then it's at 0, then it's at +1. So at this quarter point, it's at -1. At the midpoint, it's at 0. At that quarter point, it's at +1 with asymptotes on the end. So we can see that, and then we can go ahead and graph that. So let's do that. We'll go ahead and graph those 3 points and the asymptotes and see what that looks like. So we have an asymptote at 5 pi over 6 and negative pi over 6. And then my 3 points of interest here, pi over 12, -1. That is my first quarter point, pi over 3, 0, and 7 pi over 12, 1. So those are what I'm starting with. So we can look at that fundamental period here. And then if we want to graph this, it's going to go from asymptote to asymptote. This is an increasing function. It's going to look like that. Okay, so we've got our 3 points here that it's going through. If we want to zoom in on this, we certainly can do that to see the primary period. And there it is. From asymptote to asymptote with those 3 points. If we want to zoom it out, we can do that as well. And now we see how this repeats itself. But again, from primary asymptote to primary asymptote, that is our first cycle of that function. All right, let's take a look at y equals 2 times the tangent of 3x. So let's go ahead and figure out where our asymptotes are there. So we know the asymptotes for a tangent function, typically negative pi over 2 to pi over 2. So I need 3x to equal negative pi over 2, 3x to equal pi over 2. You can see the computation. So our first example there, our first asymptote is x is negative pi over 6. And if 3x is pi over 2, we get x is pi over 6. So the midpoint halfway between those two, the midpoint's going to be 0. Quarter point between negative pi over 6 and 0, how about negative pi over 12? And between 0 and pi over 6, pi over 12. And we know for a tangent function, our first quarter point will be -1, so negative pi over 12 will yield -1. Our second quarter point, pi over 12, will yield +1, and our midpoint will yield 0, asymptotes from negative pi over 6 to pi over 6. Except, of course, we're multiplying this by 2. If we're multiplying this by 2, then we've got to multiply those tangent values by 2 to go ahead and get our answers. So these are the values that we need. An asymptote at negative pi over 6, an asymptote at pi over 6. First quarter point, negative pi over 12 will yield -2, pi over 12 will yield +2. So just to quickly show you how the software works, asymptote at x equals pi over 6, asymptote at x equals negative pi over 6, midpoint 0, 0. The first quarter point, negative pi over 12, gave me -2. Second quarter point, pi over 12, gave me +2. So here we have from 0 to 2 pi. So you can see our asymptotes. You can see our 3 points. So if we're going to graph this, going up from left to right through that way. So let's quickly do that. So here's our fundamental period from asymptote to asymptote. Midpoint, quarter point. Quarter point grows up towards the asymptote. If we zoom it out, you can see what that looks like as we have more cycles heading towards our asymptotes. And that will conclude this lesson.